Imagine a dimly lit room. You can almost smell the old paper, right? And you see those little dust motes dancing in that single beam of light? Well, in this huge, quiet space, one person steps up to make a simple request.
And behind the counter, holy cow, it just stretches back into darkness. It's a maze of steel file cabinets, millions of them. Each one looks the same and they just go on forever. It's an archive that literally has no end.
So standing between that single request and that endless archive is a gatekeeper, and they are not blinking. You've got this nervous citizen on one side of the glass and a really stern, uniformed clerk on the other. You can just feel the tension, the weight of the rules in the air. Now, I know this sounds like a scene straight out of some gloomy sci-fi movie, but what if I told you that this exact little drama, it plays out millions of times a second right inside your computer? This whole strange, bureaucratic office is a perfect way to understand how Linux, and really most modern operating systems, get things done.
So to really get what's happening behind your screen, we need to decode this whole scene. Let's meet the key players in our little office and figure out what their jobs are inside your computer.
Okay, let's start with the person we can all relate to, our nervous citizen, the one clutching that piece of paper. Who do you think they represent in the world of your computer? Well, that citizen is any program you're running, your web browser, your music app, even a little command you type into the terminal. In the lingo of the operating system, each of these is called a process. It's basically a citizen that has to ask permission to do, well, anything. All right, so what about our stone-faced official behind the counter? You know, the one holding all the power, the gatekeeper to that massive archive. Who's that? That clerk? That's the heart and soul of the operating system. It's called the kernel. You can think of the kernel as the ultimate boss. It manages absolutely everything, all the hardware, all the memory, and, for our story, access to every single file. Nothing, and I mean nothing, happens without its say-so. So that just leaves the biggest thing in the room, that huge, mysterious archive that seems to go on forever. What in the world could that be? That whole archive is your computer's storage. We call it the file system. Every single photo, every document, every line of code is a file tucked away in one of those millions of cabinets. And the kernel is the only one who knows where everything is.
Even the paperwork in our story has a real-world counterpart. That form the citizen is holding, that's called a system call, or Syscall for short. It's the official way a program asks the kernel for something. The ID badge the citizen shows, that's its user ID, or UID, which proves who it is. And that giant logbook the clerk looks at, that's the Inode Table, a master index of every file, where it lives, and who's allowed to touch it.
Okay, so now we know who's who. But how does the clerk, our kernel, actually decide to say yes or no to a request? It's not just a random guess. It's a very strict, very formal procedure.
The process is exactly the same every single time. It's a four-step check. First, the program submits its request form, the syscall. Second, the kernel checks the program's user ID badge to see who's asking. Third, it flips open its master logbook, the Inode table, to check the specific rules for that file. And finally, only after all that checking is done, the kernel will either grant access or deny it. So what do these rules even look like? They're actually surprisingly simple. For any file, there are really only three basic questions. Can you read it? Can you write to it, change it? And can you execute it, which means run it like a program? And these permissions can be set differently for three types of people: the file's owner, a specific group of users, and then, well, everybody else. And this right here gets to the absolute heart of the system. The kernel doesn't care if a program is super important or just some tiny little script. It has zero feelings. It just follows the rules. Check the request, check the ID, enforce the policy. It isn't personal, it's just policy. So at this point, you're probably thinking, man, this sounds kind of slow and complicated. Why have all this bureaucracy? And that is a fantastic question. Why does this whole office even need to exist in the first place?
Well, to get it, just think about the alternative. A system with these strict rules is secure, stable, and predictable. But a system without it, where any program could just grab any file it wanted, that would be total chaos. It'd be wildly insecure, constantly crashing, and your data would be at risk all the time. So, the benefits of all this bureaucracy are massive. First, you get security. It stops some random app from deleting your important documents. Second, you get stability, because one buggy program can't just wreck the entire system. And third, it's what allows lots of different people to use the same computer safely, knowing their files are kept separate and protected from each other. So, the next time you save a file, or open an app, or even just click on a folder, just take a second to remember that silent drama happening behind the curtain. Your simple click becomes a process, which hands a syscall form to the kernel, who then checks all the rules before heading into the file system, every single time.
This invisible, silent bureaucracy is pretty much the engine that makes our entire digital world possible. It's this hidden layer of order that we depend on every single second. Kind of makes you wonder, doesn't it? What other hidden systems are out there running our world, hiding in plain sight?